Hi guys, I'm Ankit. In this video we shall see another problem on LeetCode. Binary gap. Given a positive integer n, find and return the longest distance between two adjacent ones in the binary representation of n. If there are no two adjacent ones in the binary representation of given integer, then just return 0. So two ones are adjacent if there are only zeros separating them. So the distance between two ones is the absolute difference between their bit positions. For example, two ones in 1101 have a distance of 3. How is it 3? If we take 1001, so 1 to 0 one distance, again 0 to 0 one distance, again 0 to 1 is a one distance. So total of, if you add all this would give you 3 as the resultant distance. So what is the distance which you need to calculate here? The longest distance between two adjacent ones. So if there are 1101, so which are the two adjacent ones you can find here? These two adjacent ones. Then remaining adjacent ones is this. So either it can be adjacent with ones only, or adjacent ones means in the middle it can contain any number of zeros, but it shouldn't contain any one. If it contains one, then that will be adjacent. Okay, it's something like a girl adjacent to a girl, and in the middle if there are boys there, so these two girls are adjacent to each other in the sense if we consider only the girls. So in the same similar manner, if we take only the ones, these two ones are adjacent to each other, and the length is here 1 to 0 is 1, 0 to 1 is 1, so total of 2. In this case, it's length of 1 because 1 to 1 distance is the length. And we have to find this longest distance between any two adjacent ones in the binary representation of n. So what is the approach to solve the problem? So let's take a binary number 22 only. First, let's say how do we write the binary number. So 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4. Okay. And as you know, 2 power 0, 1, 2, 4, 8, 16. So adding up what numbers will it give you? Will it give 22? So 16 plus 4, that is 20, plus 2, 22. So it's nothing but 1, 0, 1, 1, 0. 16 plus 4 plus 2 will give you 22. So in those positions you represent 1, the rest of them will be 0. So this is nothing but binary representation of 16 number. So now with this binary representation, you have to see the adjacent bits. So what are the adjacent bits? One is these two. Okay. Next, if you see the one adjacent to this, the bit adjacent to one is this bit. So here it's a distance of 2 and here it's a distance of 1. So which is maximum of 2 and 1? That is 2. So you have to return 2 as the answer. That is what they have explained over here. And if you see the next example 8, it's binary representation 1000. You could see only one 1 is present in the binary representation. There are no any other 1. So there is no adjacent ones present in the binary representation, hence you return 0 in such case. Okay, so now let's see how do we solve this problem. So what we'll have is we'll have a variable called length. Okay, initialized to 0 and max length. So this is the resultant length actually, initialized to 0. Length means you will find length of 1 and length of 2, but you need to have one more variable to store max length, right? So initially you'll get 1, next you get length as 2. So you have to see maximum 1 and 2. That is what we have to do. And we'll have one more boolean value, let's say found 1. Okay, so let's initialize it to false. Initially found 1 is set to false. That means we haven't yet found the 1 bit with the number numbering 1. So now we start with the iteration. I hope you guys know if you do any right shift of a given number by 1 means it's nothing but n by 2. That is what it happens. So right shift of this number by 1 position will give you 1011, and if you right shift this 1 by position 101. So this is nothing but 16, right? You see this number, it's nothing but 2.0 1 2 3. So 8 9 10 11. Okay, yeah, okay, this is not a number 16, very sorry. I don't know why did I write it 16. Yeah, it's 22. So right shifting a bit by one position means dividing a number by 2. So if we divide 22 by 2, it will give you 11. So you could see right shifting bit by one position is giving you 1 1 1 0 1 1, that is nothing but 11. Okay, so that operation we'll do, and each time we'll check the least significant bit, not most significant, least significant bit, LSB. So how do you check the bit is 1 or 0? You do AND operation with 1, N and 1. So if it is 1 0 1 1, we do AND with 1 means 1 0 1 1. You do AND operation with 1. So rest of them will be zeros. So this will give you 1 and 1 will be 1. Rest everything will be 0 because this is 0. So one AND operation will be true only if both are true, right? Otherwise it will be false. So you do AND with 1 each time. So that logic is as usual what we know. So now let's take the number 1 0 1 1 0, and we have this length, max length, and found one set to false. That means we have not yet found the 1. Now initially we start with the number a bit 0, least significant bit 0. Okay, so is found for taking into count 0 into the length. When will you take the 0 into the count for length? Only if it is between ones, right? If you have, let's say, 101, if you found this one, length will be set to 1. Next again we found the 0. At this time when you have already found 1, only then length will be set to 2. If it was just this, then in this case length is 0, right? Because there are no adjacent ones. Only one is present. So if you take this example, one already present. So you will set length to 2 again. Then again you move here. This time length will be 2, right? So you do max of 0, 2. If in case we have 0, 1, okay, and in such case 0, 1 will be there. So length will be set to 1. Again this 0 will form. Length will set to 2. But you don't have one more 1. So if you don't find one more 1, you will not set max length. So that's why length will remain 0, 1. This is how we do. So initially length, since if found is set to false, will not take this 0 into count. So you do right shift apply one position, that will give you 1 0 1 1. Okay. So now this bit we have to focus. If we do AND with 1, this is 1, right? Since this is 1, here let's store in a variable called val. Let val will be equal to n AND with 1. Okay. Since val is equal to 1, you have to check. What we need to check? Is found is set to false. If found is set to false, that means this is the first one we are finding, right? We have not yet encountered one adjacent to this before. So that means we will initialize length equal to 1, and is found will be set to true now. Is found is set to true. Why? Because is found is set to false. So if is found is set to false, that means length equal to 1 and is found should be set to true. We have found the 1 now. This is what we need to do. So this will be set to true now. Next again you do right shift. It will give you 101, point here. Again you encounter one valid point. But this time is found is set to true. So here you have to check if is found is set to true, then what should be done? We have encountered one already. So that means this is a adjacent one. So this time we have to find the max length. So max length will be equal to, just write max length equal to max of length comma max length. So 0 comma 1, the maximum of these two will be what? Because length is initialized to 1, right? This one, that will be 1. So max length will be set to 1 now. And after this also length will be again set to 1. Why? Because this one will be the length for the next adjacent one. So this is these two adjacent and these two adjacent. So this is what sharing each other. So that's why again set length equal to 1 only. Okay. So this is done, and again is found is set to true because this is the what sequence of adjacent ones for the next sequence we are finding it. This one adjacent pair is over. Next adjacent pair we have to look into. So this is the new beginning of that. So is found is set to true again, and length will be reset to 1 again. So okay. Now again you do right shift. That will give you 1 0. Now you find 0. At this time, do we need to count length increment by 1? Yes. Why? We give else condition. If val is not equal to 1, again else if you have to check. If val is not equal to 1, else if you have to check what? If found. Else if found. Found 1. If of found 1. That means if val is not equal to 1, that means it's equal to 0. If the bit is equal to 0 and is found 1, is found means found 1. If found 1 is set to true, that means we have one adjacent, we have one starting sequence of one bit is already occurred. So this time length should be incremented by 1. So length will be incremented. That's it. So length will be set to 2 now. Next again you do right shift, that will give you 1. So this time 1, so this time val equal to 1 and is found is set to true. Found 1 is set to true. Yes, it is. It is set to true. So that means we have already found a 1 and this will be the adjacent one to that one. So that means we have to find the max length. The max length will be equal to length comma max length. So length is 2, max length is 1. So max length will be reset to 2. And after that again length will be set to 1 because this will be a new beginning of the next array. Let's say here after 1 we have 0 0 1. So again this will give you length as 3. 1 2 3. And is found 1 will be set to true again. So this is the basic approach to solve the problem. So ideally what is the logic is, if you find value, or if you find bit equal to 1, then just check whether that bit has been already found or not. That one is already found or not. So found one is set to true, then you find the max length and reset the length equal to 1 and found equal to true for the next sequence of ones to find it. Otherwise, what if you find the value, if you find the bit equal to 0, means just check whether found one is set to true. If found one is set to true, that means this is the length which we need to add. That 0 will be added to the length. So yeah. So first what we need to do is, as I said here, we'll have a variable length equal to 0 and max length also set to 0. Okay. So and one more boolean value we need to have. Okay. So this is C++. So just bool v, right? So found 1, that will be set to false. We have not yet found 1. So while n greater than 0, so first we need to do, let's say int val equal to n and 1. So that let's store that bit. Then n will be right shifted by 1 position. So this is a bit. As you write a equal to a plus b, how do you write it? A plus equals to b, right? Same way, n equal to n right shift by 1 position, right? N right shift equal to 1 position. Okay. So now what happens? You have to check if val equal to 1. If it is equal to 1, you have to check if found 1 is already set to true. That means this is the time to find the max length. So max length comma length, and then again length will be reset to 1 and found 1 will be reset to 2. So after this what we should do? Else condition. What if value is equal to 0? Check if found 1. That means if you already found a bit 1 before to that, that means this 0 should be incremented to the, should be contributed to the length. At last return max length. Yes. Yeah. And for Java also same logic, nothing changed. Only math.max is a function which we need to use. Yes, successfully submitted. If you understood the concept, please do like the video and subscribe to the channel. We'll come up with another video in the next session. Until then, keep learning. Thank you.